Hello, and welcome to this video on determining a sinusoidal equation from given information. This is intended for students in Applied Math 40S, taking your sinusoidal functions unit. And what we're going to look at is the type of question where you're going to have some real life thing, like a Ferris wheel as you see pictured here, or waves on a beach, or anything moving back and forth or up and down in a repeated pattern. Take some sort of real life periodic function and get it into your calculator and figure out an equation that most closely matches what's happening in real life. So we're going to do that through an example. So we're looking at a Ferris wheel, which is a carnival ride that spins around and around if you're not familiar with it. You board the Ferris wheel, according to the question here, you board the Ferris wheel at the bottom, and then you ride in the car around the Ferris wheel. So the height of the Ferris wheel is the height of a person riding it is periodic because it will go up and down and repeat itself as the wheel spins around and around. So what I'm going to try to do is find 5 important points. I'm sure your teacher talked about the 5 important points that I'm going to then put into my graphing calculator and perform a sinusoidal regression to get an equation that matches the situation. So let's look at some of our details. We have, we know the height of the Ferris wheel. We know the height the person boards the Ferris wheel, which is the minimum height of this function. We know the maximum height of the function is given here. Maximum height is 64 meters off the ground. And we know it takes 48 seconds for the ride to make one full revolution or one spin all the way around. So let's start by drawing a little graph that's going to help us figure out those 5 important points, like I said, to put into the graphing calculator. Time is going to be my independent variable, my x-axis variable, and height off the ground is the variable for my y-axis. Okay, so it says a rider boards the ride when the car is at its minimum height of 4 meters off the ground. So at 4 meters, so I'll put a little 4 there, and this is in meters. And the time will be in seconds, and I know that because they gave us a time in seconds. At 4 meters, the person gets on the ride. So at time of 0, the person boards the ride. Okay, I know they're going to go up to a height of 64 meters. What I don't know is how long that's going to take yet. I do know it's going to take 48 seconds for the ride to make a full revolution. So somewhere down the line here, and it really doesn't matter how far you go, I'm going to say, well, here's 48 seconds. And it took that long for the ride to make one full revolution or one full go round. So if you're the person that got on at 0 seconds, after one full revolution, you would be back at 4 meters high again. Now the maximum height is going to occur halfway through the ride. You're halfway around the circle. So halfway between 0 and 48 is 24 seconds. And at 24 seconds, I know I'm going to be 64 meters off the ground. So I'm going to put a dot up here. And I'm just going to go over here. And this is just a little sketch. It doesn't have to be a perfect graph. You don't even necessarily need the graph, but we like to sometimes look at it when we're getting the data we want to put into the calculator. So at 24 seconds, halfway through the ride, you're at the maximum height. There's 3 points, but your teacher, I'm sure, talked about the fact that you want 5 important points in order to get the most accurate equation we can. So what I'd really like is, I know there's a midline here, halfway between the min and the max. So I'd really like the 2 points that are on that midline. So where is the midline? If you go 64 plus 4 is 68. 68 divided by 2 is 34. So halfway between the minimum of 4 meters and the maximum of 64 meters is a height of 34 meters. When you're halfway up the ride, you are at 34 meters. So when will that happen? Well, to get halfway from the min to the max is going to take half the time it takes to get from the min to the max. So to get from the min to the max is 24 seconds. So half that time would be 12 seconds. And I know I've got a point there. I'm going to draw it kind of nice and big just to differentiate it from my little dotted in median. So we go from the min through the median to the max. We're going to go through the median again to the min. We're going to hit the median here again halfway between 24 and 48 seconds. So I know that's 12 seconds after 24 seconds, or you can add 24 and 48 together and divide by 2. However you slice it, you're going to get 36 seconds, and I'm going to put a dot there. So that shows one full revolution of the Ferris wheel. And I'm a little shaky drawing with this tablet, but I think you get the point. And it will repeat on and on, not forever. They will eventually let you off the Ferris wheel to eat. But it repeats on and on for the length of the ride. So what do we have? Well, we've got time, which is our x variable, and we've got height, which is our y variable. So I'm going to make a little table. So time, I've got times of 0, 12, 24, 36, and 48. At 0 seconds, I'm at 4 meters. At 12 seconds, I'm at 34 meters. At 24 seconds, I'm at 64 meters. At 36 seconds, I'm back down to 34 meters. And at 48 seconds, I've gone all the way around, and I'm back where I started at 4 meters off the ground. So I'm going to use that information. I'm going to go to my calculator. You can see I've reset my calculator memory, and I'm going to put that data into the calculator and perform a sinusoidal regression in order to get the equation. So to put the data in, under Stat, and then Edit, the first option, put your X numbers into L1. So we've got 0, 12, 24, 36, and 48. And then I'm going to go over, I'm going to put my Y numbers into L2. So 4, 34, 64, back down to 34, and then back down to 4. So I generated the graph from the information. That gave me the table. I put the table in my calculator. Now I want to perform a sinusoidal regression. So I'm going to hit Stat, and I want to go under the Calc menu where all the regressions are hiding out. And I want to go down, 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 down until I find the sine regression, which is option C. Okay, it's right down near the bottom of the options. You could also just from option 1, you could go up. It'll take you to the end of the list and you find sine regression. And I'm sure you've been through this with your teacher, but we're going to leave iterations at 3, leave X list and Y list at L1 and L2, leave the period out. There's some debate sometimes whether we should put the period in since we know the period is 48 seconds, but for what we're doing on the calculator, normally we just leave it out. But we do need to under store reg equation. In case you need to answer questions about this later, you want to put the regression information into y equals so that it will graph the corresponding function. So under store reg EQ, I'm going to go vars, arrow over to y vars. I want function, press enter. I want any one of the y graphs. So the first one's fine, press enter. And make sure you've got y1 in there. And then I go down and I hit calculate. After calculating, it gives me my sinusoidal equation. So all I have to do now is take the A, B, C, and D and write them in place where you see them in the equation up here. So we end up with a final answer of y equals, don't forget the y equals, it's part of the equation, y equals A times sine. You can write the times in if you want, but you normally don't. Bracket B. Now we're going to round to 2 decimal places, so B is 0.13. X. Oops. X. And then it says plus C, but C is negative, so I'm going to put minus My C value rounded to 2 decimal places, so that is 1.57, N bracket, and then plus D, so plus 34. And you can see that is what we said the median should be, so that's good. Okay. And there's our equation from the question. So now you could go further and answer questions about that equation, but that was our focus here, was just how do you come up with the graph and then the table and then the equation off of the calculator. So that was finding a sinusoidal equation from given information. You'll notice as you go through, the questions can differ fairly significantly in the information they give you, but they will all be the same in the sense that you want to find 5 important points out of the information given, so you can put those 5 points into your calculator and do a sign regression. Okay, thanks for watching.